11, a monthly phone bill, and this is a way of writing a function, is B of M, the function of M, okay, consists of a $26 service fee plus $13 per minute M of long distance calls. And then it's giving you the equation. Again, they're just calling it a function. So instead of X and Y, they're using M and B. So basically this equation would be Y equals, and I'm going to turn this around, 13M plus 26. Now this M doesn't stand for the slope, it actually stands for minutes in this case. So that Y would stand for the total phone bill. Get it right here. Total phone bill and minutes. So what they're saying here is, in order to use this service, I have to pay $26 right off the bat. $26 service fee. So whether I use the phone or not, I have to pay $26. Then I'm going to add to that 13 cents, so this is how we write 13 cents in dollars, for every minute. So you know that if you talk for 5 minutes, you'd multiply 5 times 13, so that's what that means. So here we wrote an equation. The total bill, B, equals $26 plus 13 cents for every minute. So it says draw a graph for up to including 120 minutes of long-distance phone calls. So here's our graphs. And estimate the bill of 88 minutes of long-distance recall. Well, first of all, if I write it like this, okay, so let's change this around so we have our variable part first, like our X part. So in other words, this would be Y equals MX plus B. This is our y-intercept, right? Well, go to the graph that has 26 as your y-intercept. There's 20. There's 26. There's 26. There's 20. So these two are saying I paid $20 to begin. So now I'm there. Okay, then I have to go 13 cents every minute. Well, that's kind of hard to look. So I'm going to do 88 minutes. So I'm simply going to substitute 88 for the M and figure out how much my bill is. So 88 times 0.18, so that's 64, 64, 68, 8, 8, 4, 16, 15, 2 decimal places. So it's $15.64 for the minutes, and then I have to add $26 for the fee, so I get about $41.64. So that looks like it's about $41. See, there's our 40. It's a little bit more. And so does that. But look at our answers here. Okay? Estimate that bill. This is only 7. That's 40. We know it's about 41, so that's our answer. Which graph has all the points from the table below? Well, right off the bat, remember, if I have 0 at my x-coordinate, then my y-coordinate is the y-intercept. So -1, yes, yes, no, and down here, no. So these two are possible. Okay, let's check our slope out. So I'm going positive direction, and one's a difference. Here I'm going in a positive direction, and 3's a difference. So my slope is rise over run. It's positive. Well, this graph goes up and to the left. That's negative, so this one has to be it. Okay, choose the correct equation for the function table. All right, so we need to know slope and intercept. So first let's find the slope. So that's going positive direction, and there's a difference of 8. That's going in the positive direction, a difference of 2. So my slope equals rise over run. So my slope is 4. Well, there we go. That's the only one that has a slope of 4. We don't even have to worry about the y-intercept. That was easy. Which of the following relations behaves in a linear fashion? So remember, linear means my pattern has to be the same all the time. So the heart rate of a sprinter from warm-up to 1 hour after a race. Well, you know that's not the same all the time, because as he's warming up, his heart is getting faster. When he sprints, his heart beats real fast. After he warms down, an hour after his race, his heart is going really slow. So that's not the same. The distance traveled by an accelerating car. We know an accelerating car, if here's my graph, here's where he starts, kind of goes like this. Okay? It's not the same speed all the time. The outside temperature measured hourly over a 24-hour period. Well, we know when the sun comes up in the morning, it's a little bit colder. As the sun gets higher and higher in the sky, it gets hotter. As the sun starts to set, it gets cooler. So it's not the same every part of the day. And finally, the distance traveled by a car traveling at a constant rate. There's the key word. Constant means the same, so that's our answer. Which, when graphing the line y equals 1/2 x minus 1, how do you move from one point to another on the line? Well, we know when you move, it's like climbing the stairs. It's our slope. So we know that's up 1 and over 2. So 2 units up? Nope. 1 unit down? Nope. Okay. 1 unit up? Yes. 2 units to the right? Yes, because it's positive. And we know going to the right is positive. This would have been a negative slope. Which graph represents the line containing negative 2, 1 and having a slope of 1, 4? Well, let's plot this point. Negative 2, 1. Negative 2, 1 would be right there. So that's not right. Negative 2, 1 would be right there. So that's not right. Negative 2, 1 would be right there. So that's not right. Obviously, negative 2, 1. So there it is. D. So some of these problems just aren't very hard if you think through them. If you think about what the question is asking you to do and you look at the answers, that's good test-taking strategies. Use the elimination method. A car is traveling at a speed of 30 miles per hour. Which of the following graphs best represent the distance the car has traveled? So basically every hour the car travels another 30 miles. So first hour, 30 miles. Second hour, 60 miles. Third hour, 90 miles. 4 hour, 120. Well, what did I just make? Hopefully some of you said you made an X and Y t-table. So now I can just go and look for the graph. All right? This is our distance. This is our time. This is our speed. This is our time. So notice you have different variables here. So after time, after 1 hour, I went 50 miles. After 2 hours, I went 100 miles. Well, that's not what I did. After 1 hour, I went 30 miles. So this isn't right. So on this one, it changes here. So I go 1 hour, 30 miles, 2 hours, 60 miles, 3 hours, 90 miles, 4 hours, 120. And of course, that matches our graph. So that's our answer. We don't have to look at the other ones. All right. So now we have a couple all-stars in here. So if the x-intercept of the graph is changed to 0 and the y-intercept remains the same, the graph will not pass through blank quadrant.
D.
All right. Ooh, where did the D? Well, let's see if I think they just guessed probably. So the x-intercept of the graph is going to change to 0. Right here is where it's at now. So we need to move it there. The y-intercept remains the same, so we're not going to change that. So here's going to be our 2 points. So really what's going to happen is on this line, we're going to take it, and we're going to move it over right there. So now it crosses or has those 2 points in common. So which quadrant does it not go through?
A.
And they're right. Doesn't go through any of them. Given the graph of the line, what happens to the slope if the x-intercept and the y-intercept are changed to 4 and negative 4 respectively? Respectively means I keep in order. So the x-intercept will be 4, the y-intercept will be 4. So let's plot them. Y-intercept, x-intercept. What happens to the line, ladies?
Parallel. Slope remains the
Oh, it stays, the slope remains the same because they are parallel. So now, here's what to do in algebra. What happens to the slope if they're perpendicular?
It's the opposite reciprocal.
So what that means is if I give you an equation 1/4 x, and I ask one of these ladies to make an equation that is perpendicular, they would do this without having to think about it. Flipping it is the reciprocal, and then opposite means it would be opposite sign. And of course, we don't put a 1 down there, we just do that. All right, pretty smart. Okay, one more. Which of the following have the same slope? All right, well, let's do this one first. Positive, right? So up 2 over 1. Up 2 over 1, so the slope is 2. Okay, oh, here's a slope of 2. here's a slope of 1/2. Okay? And these two, which of the following have the same slope?
It's B, because C is 1/2.
So it would be
'Cause
A and
is 1/2.
B, but on this, it looks like this is a multiple answer problem. So it would be A and B, and then let's check this one out. Okay? Did you guys ever do this in algebra to find slope?
No.
Instead of the formula?
We did the formula.
So this, look how easy this is. You just write this down. Okay, I'm going bigger, so it's +1. I'm getting bigger, it's +2. 1/2. Because all this is, think of this. Here's your slope formula,
Mr.
right?
Butler taught us the
Look,
formula.
y minus y, x minus x, correct?
Yeah.
Well, look what happens. All I'm doing with the function table is I'm just writing it a different way. See how it's y minus y going down, down? So,
Mr. Butler never taught us that. Last
Yeah.
Mr. Butler taught us the
I'll
formula.
tell you, I probably know a little bit more than Mr. Butler, I think. Maybe. He's pretty smart in lots of stuff, but I think I got him at math. So anyway, that's a little easier, especially if you start to have minuses and negatives, and so forth. So that's easier. So these two are the same, and these two are the same. So I'm not quite sure which of the following have the same slope. Well, A and B have the same slope as C and D. So I'll have to double check what we really need of that. Anyway, excellent job. Say goodbye.